So the topic of the day, route reflector, followed by configuration only theory. Actually, it will not be asked anywhere, and you won't see anywhere in the production. The reason why I'm teaching you is because there is something called configuration. People may ask you in interview just to put pressure on you. So configuration followed by backdoor, and then I don't think there will be a time today, so tomorrow will be dampening and small topics like allow AS, local AS, and prefer AS. Prefer, allow, local AS. Please remind me these two topics tomorrow, and today we finish this. Arindra, please make a note. With this, our CCNP syllabus gets over and BGP gets over. So before we go, Girish, you were asking about the route reflector is used to overcome full mesh constraint, meaning because of IBGP split horizon, route learned from one IBGP is not given to other IBGP. For this reason, we used to have full mesh. Otherwise, you need to have MPLS VPN. But if you don't want to use MPLS, but to distribute the routes without full mesh, you can have a kind of hub and spoke design and route reflector. Say for example, I have PE1, PE2, PE3, PE4. This is all provider edge. So you should design an autonomous system something like this. Usually, to overcome the IBGP split horizon rule, we make full mesh. But now you don't need to make full mesh. You just form neighbor only with this one. Likewise, every router will form only neighbor with the hub router. Only with the hub router you form neighbor. You don't need to form neighbor with the other PE routers. And this hub router will be made as a route reflector server. That's it. Because it's a route reflector server, these are all clients. Now, when a route is advertised to EBGP neighbor, the EBGP neighbor will carry it into its IBGP neighbor. Usually, IBGP will not advertise to other IBGP, but because I make this as a server, all the clients of the server, who are the clients? P2, P3, P4, they all receive the update now. Likewise, when a route comes here, it goes to RR, and RR advertises to all the clients. Now, route learned from a server, a client can give it to EBGP, no problem. But a client cannot give it to another IBGP. You see? So the route that is learned from the RR server, the client can distribute to eBGP but not to IBGP. This is one important rule. Not only that, a route can also be given to a non-client. Who is a non-client? Let us say this is not a client. Pay attention, close. This is very important. I'm not going to do this demo, okay? You're going to do the lab. You're going to do this lab and you will come back and ask me doubt. This is not a client. PE2 is not a client. So if alpha is advertised to PE1, it will go to PE3, it will go to PE4. There is no doubt in that. But I tell you, it will also go to PE2 if PE2 is connected to eBGP and if some routes of this eBGP is used by RR. Let me elaborate this. This is important. In RR, this is the part where people get confused. I'm drawing again PE1, PE2, PE3. Why they are called as PE? Because they are connected to C's. C3, what is CE? They are other autonomous system. Now for our better understanding, what I'm going to do is I'm going to have some network. Now, let's say this is non-client. This is the only client. And this is also client. This router will know now 1.1.1.1. So I want to ask a question and you should answer. Tell Arindra, will PE3 learn about all these three network? Means the other two networks? Will it learn from RR or not? Yes, because it is a PE a client. It's a client. So this router is going to have 3.3.3.3 from eBGP and 1.1.1.1 and 2.2.2.2 from the server. As a result, this will know now 1.1.1.1 and 2.2.2.2. Do you agree? eBGP will give. Likewise, here also you will know 2.2.2.2, 3.3.3.3. You agree? This reflection will happen, no? Now, these things everyone know. What many people do not know is even this router will know about 1.1.1.1 and 3.3.3.3. That's what I'm trying to explain you. Focus. PE2 is not a client, but a route learned from an IBGP will be given to this router because the route that was given by this PE2, what is that network? What is the network? 2.2.2.2 was used by RR to give to these clients. So whatever those clients gave, like 3333 and 1111, it will give to non-client. As a result, those routes will be advertised to eBGP and it is learned. Did you understand this very well? Girish? Now I'm going to next step. This is the final step. If I'll have another IBGP, it will not be given. It will not be given to Y router. If I'll have X router here, okay, let me put Z router. If I have Z router, it will be given. Why? A client can give to a non-client. The route that got reflected and came, no. The client will give to non-client as well as eBGP. But a non-client cannot give it to another non-client. Understood or not? Hello? Please answer. Is it clear? Thank you. I want you to simulate the same topology. Wait, let me make it small. Simulate this topology, test it, and enjoy it. If you don't get the result, then come and ask me. I'm putting this in your hand. The command to configure route reflector is very simple. You go to the server and say, under BGP, neighbor is this router, let's say this router, IP address, PE3.PE, 3.PE, 3.PE, 3, route reflector, client. That's all. That's the command you need to type. Likewise, you do it for neighbor P1, 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 P1 route reflector client. P1, P1 is what? It's the IP address of the neighbor. Can you do this? Or you want me to do this? Same problem. What is that? Route learned from one IBGP cannot be given to another IBGP. Can also be solved by another concept called confederation. This is theory only. Don't try this and waste time. Because we don't have this anywhere in the production. We have MPLS and we form VPN using MPBGP. So you get hub and spoke design logically. Sometimes we may also have physically. And we use RR. That's all. We use RR. But before MPLS was becoming famous, before layer 3 VPN was gaining importance, people were focusing on this called confederation. What is confederation? Creating sub-autonomous system inside an autonomous system to provide eBGP environment. Repeat again. Repeat. Creating sub-autonomous system inside the primary autonomous system. Why? First of all, let me draw this. Creating sub-autonomous systems inside the primary autonomous system Why you create this? In order to provide EBGP relationship for the router. Listen, if I'll have 4 router, you need to answer for me to go move faster. The route that is coming from here 1.1.1.1, will it be seen in R2 or not? Will it be seen in R3 or not? If R3 cannot know it, R4 cannot know it. R4 cannot know it, R5 cannot know it. Same way, 2.2.2.2, R4 will know, R3 will not know. Sorry, R3 will know, R2 cannot know. R2 cannot know means R1 cannot know. This R7 also cannot know. So you can use route reflector very well, but configuration can also be used. How you know? You create sub-autonomous system so that these two will think I'm a EBGP. See, these two router will think, X and Y will think I'm an IBGP because this is 654.1.431, this is 654.3.2. Originally, they belong to the Confederation ID 200. Originally, they belong to Autonomous System 200. But you create this so that these two route learned coming from here, if it is IBGP, it won't give, but if it is EBGP, it will give. Arindaram, understood or not? So this is an EBGP, it will give to IBGP, it will go out. So from EBGP route comes to one IBGP, it will give, to other IBGP it won't give, but it will give to EBGP, and this router will give to IBGP, and this will give to the EBGP. Problem solved. That's all configuration. If you really have much time, go and do research. It's not necessary, it will be a waste of time for you. But I'm just teaching you this so that if someone asks what is configuration, you can simply tell. But if someone is asking what is BGP configuration, they are simply putting pressure on you. They are not really good people. Hmm. Hmm. This one, right? Route reflector. Okay. The question is, you need to get routes everywhere, but you won't make PE2 as a client to achieve this. P1 and P3 are clients. P2 is a non-client. And P2 will learn the route even though it's a non-client. But the difference between client and non-client is a client can give it to another router, give the routes to another IBGP router as well as EBGP router. A non-client can give only to EBGP router but not to IBGP router. That's all. I want you to test. This green router is optional. You can connect it and test, or at least you connect it. You do up to at least this level. Welcome. BGP backdoor. In what situation it is used? Let's say you have an autonomous system here, another autonomous system here, Another autonomous system here. Or you may have many autonomous systems here. That doesn't matter. Between these two, you have EBGP. Between these two, you have EBGP. Between these two, you have OSPF or EIGRP or RIP, something else. Now, I am going to ask you a question. Think 2 times or 5 times or 50 times. Give me only the correct answer. We have a network 1111 advertised from here, 2222 advertised from here, and 3333 advertised from here. My question to you is, I said EBGP, this is autonomous system 10, autonomous system 20, autonomous system 30. Again, I'm underlining something. We are not running BGP here, we are running IGP here. My question to you is, anyone can answer. Right, let's continue. See, we are focusing on backdoor. I have underlined that EAGRP or OSPF is running. It's not EBGP. Question to you is, what will be the path taken by R1 to reach 2.2.2.2 network? What will be the path taken by R1 to reach 2.2.2.2 network? Who said this? Arindra. Okay. Why Arindra? Very correct. Thank you. Excellent. The administrative distance of EBGP is only 20. Administrative distance of EBGP is only 20. The administrative distance of both EIGRP and OSPF is always bigger. It's more. It's big than 20. As a result, it is taking the R3 path which you do not prefer. You don't like. You want it to go straight like this. Maybe you are physically directly connected to shortest path, or maybe you have a tunnel like IPsec something where you run EIGRP in it. You want it to go via secured tunnel. IPsec or GRE or DMVPN, something like that. You do not want this to be taken via router 3. You want it to go via the link where IGP is enabled. Only in that case. Listen, this lab I have already done in the previous batch. So I'm going to give you the recording only. I'm just telling you what command to type. That's all. There is nothing more in it. Just one command. So listen, now itself you asked out. You are going to do it as a homework. If you need clarification, you will refer to the video. So listen, on R1, you need to simply go and say router BGP 10 network. Usually we use the network command for our own networks. But now you are using the network command for 2.2.2.2. Mask, very important, mask. Don't forget mask. What mask this R2 is advertising? If he is advertising /24 mask, then you need to say 255, 255, 255, 255, backdoor. That's all. You put that in this router, immediately this router will make Administrative distance as 200. Earlier it was 20. Now it will make it as 200 so that EAGRP or OSP or whichever you run here will be preferred. And this BGP will go into what failure? Can someone complete? What failure? RIP failure. What is RIP failure, Rindra? Administrative distance higher. Because administrative distance is higher, 200, even though BGP has given a valid and best path, I'm not able to use it because a routing table algorithm called RIB, routing information base algorithm, prefers the source whose administrative distance is lower. That's all. That is what RIB failure means. RIB failure is not a serious problem. RIB failure is a valid route given by BGP, cannot use because there is some other source with better administrative distance. That's all. You understood that? Before you enabled backdoor, was there a brief failure? No. Now, after you enabled backdoor, what really happened for 2.2.2.2 network? No. What I want you to tell is related to administrative distance. After you made that network as 2.2.2.2, earlier it was coming with administrative distance 20. Now, what is the administrative distance it is coming? What? 200. Not coming. Router 2 will make router 1 will make the administrative distance as 200. That is what called as RIP failure because it is made as 200. EIGRP route is preferred. When it was 20, it was actually a RIP failure for EIGRP. Now you understood what is RIP failure. When it was 20, it was actually a RIP failure for EIGRP. But in EIGRP, they are not saying that because it don't show like that. It will say unable to use. EIGRP will not say RIP failure. It will say unable to use. If you go to the topology table in EIGRP, you will see 2.2.2.2 unable to use. But after you configure backdoor, this is becoming 200. So BGP route becomes unable to use. That is what called as RIP failure, unable to use. And now the route goes via EIGRP or OSPF, whatever you run. Is this backdoor clear for you?